Hi friends, good morning. Myself Mr. B.R. Sanap, lecturer in Mechanical Engineering Department of KK Polytechnic Nasik. Friends, today we are going to discuss about basic of engineering material. Especially we will discuss about microstructure and types of microscopes. So first, that is the microstructure. Here, the arrangement of phases and defects within the metal is known as the microstructure. It is the structure of metal or alloy observed after etching and polishing under a high degree of magnification. So the magnification is above 25x and maximum at 2000x. So the microstructure examination is generally performed using optical or electron microscope to magnify features of the metal under analysis. So in simple words, microstructure is what we see under a metallurgical microscope on nanoscale. So microstructure determine the physical and chemical properties of the metal. So next, there are different types of microscope. Optical microscope is there, electron microscope, then scanning probe microscope, and next that is X-ray microscope, or we can say ultrasonic microscope. So one by one we will see. The optical microscope. The main principle of optical microscope is to pass a light through or onto the surface of specimen and examine it under magnification. The main components of optical microscopes are objective lens, eyepiece, condenser, and light source. The function of each component, that is the objective lens, it magnifies the object. Then function of eyepiece is it enlarges the image but does not increase the resolution. Then condenser is there, so it focuses the light source onto the specimen for uniform illumination. Then again, this consists of number of parts, that is the major elements, that is the state, tubes, then focus adjustment, objective, and eyepiece. So the function of state is a flat movable table supporting specimen. It can be adjusted vertically up or down. Then tubes are there. The vertically movable tube contains an eyepiece, objective and plane reflector. The tube length varies from 160 mm to 250 mm. Then another element, that is the focus adjustment. The lens of microscope carries the two knobs for coarse and fine adjustment. Then objective lens is fitted down at the end of the tube. It helps in a quick resolving the structure of specimen. It collects lights diffracted by the specimen. And next, that is the eyepiece. The primary image can be enlarged with the help of eyepiece. The eyepiece are available in different magnifying powers, such as 5x, 10x, 15x. Then we will see the working of this optical microscope. The illuminating light beam is transmitted through a specimen before forming its image. The image is formed by contrast between different features of the specimen depending on the illuminating source. Deviation of the incident light beam from the illuminator into the objective lens is done by a plain glass reflector inclined at 45-degree angle to the axis of the incoming light from the source. The light incident upon the specimen is reflected back from the specimen surface and pass through the objective lens and glass reflector to form the final image. The enlarged image of bright area of the specimen surface can be observed through the eyepiece. Then second instrument, that is the electron microscope is there. So electron microscope uses a beam of electrons to form an enlarged image of microstructure. In optical microscope, the light beam is used as a source of illumination. So in construction, an electron microscope is similar to that of an optical microscope. The major difference is in the type of lens. Here, instead of lens, coils are used. The whole setup is enclosed in a vacuum. At the top there is a basic part of the microscope, that is source of electrons as a electron gun. Uh, a, a condensing coil is used to condense the electron beam, and the scanning coil is arranged in between condensing coil and specimen. The electron detector is used to collect the secondary electro scattered from specimen. Then we will see its working. In working, a stream of electrons is formed in a high vacuum by electron gun. These primary electrons are accelerated towards the specimen by the anode. The accelerated primary electrons are made incident on the specimen through the condenser lens coil and scanning coil. These high speed primary electrons, when falls on the specimen, produce low energy secondary electrons. In the detector, the secondary electrons converted into the electrical signals by a photomultiplier. The electrical signal is then amplified and displayed on the cathode ray tube. So this is the working of the electron microscope. Then next topic, that is the sample preparation. So a sample preparation consists of series of operations, namely sectioning, mounting, grinding, polishing and etching. So each of these stages we will discuss one by one. So the first is sectioning. Sectioning is the cutting of a small volume of specimen of convenient size from large volume without any damage to the microstructure. Changes are possible while doing cold work or hot work. As possible, cutting or shearing with hacksaw should be avoided. So cutting with bonded abrasive wheels and suitable coolant is the best way to minimize heat and deformation. So next step of sample preparation, that is the mounting. So it is nothing but holding the specimen in a small block of material, usually plastic, to ensure further operation like grinding, polishing. Each of the specimen is mounted by placing it in a mold which is cylindrical in shape and filling the mold with a suitable material that the specimen and hold it firmly for further operation. So mounting is done for two purposes. The first is for making handling convenient, and second to protect the edges of specimen during grinding and polishing. So there are two methods of mounting the specimen. So first is the hot mounting and second is the cold mounting. So hot mounting is done by mounting the specimen in a cylinder of hard polymer under pressure and elevated temperature in a molding press. So molding material used in this process are thermosets and thermoplastics. So another, that is the cold mounting, need not require pressure and temperature and is a fast method of mounting. In this method, the specimen is placed at the center of metal ring on a glass plate. Liquid molding material like epoxides, polyesters and acrylics is to be poured into the ring to cover the specimen. So next step, that is the third one, that is the grinding. Grinding operation is done to remove scratches left from previous operations. So cutting operations, it is one of the most important operation in specimen preparation. The grinding procedure involves several stages using a final grinding paper each time. Those are rough grinding, medium grinding and fine grinding. Rough or coarse grinding is done on a wet belt grinder with 120 and 240 grit number belts. It removes previous cutting tool marks. The intermediate stage grinding uses the paper of 240 and 400 grit number. During the grinding, the specimen is moved forward as well as backward. Then next, that is the polishing. The purpose of polishing is to remove damage produced during cutting and grinding and to get the scratches free. Whereas like surface polishing is done as a rough and fine polishing. Rough polishing is accomplished primarily with a diamond abrasive ranging from 9 microns to 1 micron in the form of oil soluble paste. It is placed on the nylon cloth covered surface of rotating wheel. The specimen should be held firmly in contact with the polishing wheel, but excessive pressure should be avoided. During polishing, the specimen should be rotated or move around the wheel so as to give an even polish. The specimen should be thoroughly cleaned with water and dried with the alcohol between each wheel. Aluminum oxide, that is Al2O3 powder particle size zero point zero 0.05 microns, is used for the polishing. Fine polishing is done at slower speed of 100 to 150 rpm using a napped cloth. So next, that is the etching. So each but polished surface cannot be used for microscope examination, as it does not show surface characteristics such as phases, inclusions, porosity, cracks, then intergranular corrosion. Etching is defined as the process to reveal microstructural details by selective attack of metal specimen with an etching reagent. So etching reagent usually dilute acid or dilute alkalis in a water, alcohol or some other solvent. The most common type of etching is a chemical etching. Etching is generally done by swabbing or immersion. The choice of chemical etchant is depend on the specimen that need to be etched. Before etching, the surface of polished specimen must be clean. Nitrile, that is nitric acid alcohol mixture, is the commonly used etchant for common ions and steels. The etching solution is then applied on the specimen with a dropper or cotton swab. Depending on the specimen and nitrile concentration, etching time vary from 10 seconds to 1 minute. So after each etching, the specimen should be thoroughly washed in running water, followed by drying off with alcohols. So these are the steps or methods of sample preparations. So the next, that is types of etchants. There are four types of etchants, that is iron and steel, copper and brass, aluminum and alloy, stainless steel. So etching reagents for different metals and alloys are given below. The first one, iron and steel. So etchant name is nithal, and the composition is 1 to 10 milli nitric acid and 100 milli ethanol. Then here the composition 2 to 4 gram picric acid, 100 milli ethanol. Then second, copper and brass. So ethant is a ferric chloride. So composition is 5 gram ferric chloride and 10 milli hydrochloric acid and 100 milli water. The next, that is aluminum and alloy. So the ethant is killers H. So here composition nitric acid 5 milli, then hydrochloric acid 3 milli, then hydrofluoric acid 2 milli, and distilled water 190 milli. The fourth one, that is stainless steel. So here etchant is Willis reagent. So composition is glycerol 45 milli, then nitric acid is 5 milli, then hydrochloric acid 30 milli, and ethanol is 100 milli. So these are the types of the etchant. So thank you very much.